All right, so this is the skier problem. A 90 kilogram skier moves down a slope at a constant velocity. Determine the normal force and force of friction. What is the coefficient of kinetic friction? Okay. All right, so first thing you want to notice is that it's going to be kinetic friction, okay, because it's moving. All right. And then what I suggest that you do, what I like to do anyway, is I like to draw the diagram first right on the picture because it makes it a little easier to see. Okay, so I like to draw my FG. Okay, my FN is sort of this direction. And I guess there's going to be some kind of friction. All right, and it says he's moving at a constant velocity. Okay, all right, so after you kind of set up your axes, you want to think of it as parallel and perpendicular. Okay, so I'm going to sort of redraw that over here. All right, so then my FF is going to go sort of off to the left, no, the right. My normal force is going to be on the y-axis, and then if I kind of tilt my head, I can see that that FG is sort of third quadrant over here. Okay, and remember, this is the angle between the vertical. It's the same angle as the ramp for, I don't know, lots of geometry reasons. Who cares? All right, so that's always going to be the angle. All right, so when I split apart that FG, right, I have my FG and my FGY and my FGX. That's the 35, okay? Right, so then I can see that my FGX is going to be FG sine 35, and my FGY is going to be the cosine, okay? Because, right, the 35 and the Y are adjacent, okay? All right, and then the inclined planes are pretty much always going to split up like that because they're almost always going to give you the ramp angle, right? They're going to probably give you the ramp angle, okay? All right, so again, it really doesn't even matter what we're solving for. All right, so the sum of the forces in the x direction are 0 because constant velocity, okay? And the sum of the forces in the y direction are 0 because constant velocity. All right, I'm going to set up my coordinate system to go down the plane as positive. So I'm going to have, well, actually probably should have redrawn that first. Okay, so when I redraw it, right, I'll have my FGY, my FF goes like that, my FN like that, and my FGX like that, okay? All right, so then I'm going to have FGX minus the force of friction equals 0, all right? So the force of friction is FGX, which is FG sine 35, okay? Since they give me the mass of the skier and everything, right, I'm going to go ahead and just find the weight. Okay, and I'm just going to go ahead and get a number here. Although you can leave this, right, you can leave this as, right, mg sine 35, okay, or mg sine theta if you're leaving it in all variables. Okay, all right, so then 900 times sine 35, sine 35. Make sure you're in degrees, 516.2, I guess, whatever, that, okay? All right, if I do the same thing in my y direction, I'll have Fn minus Fgy equals 0. Okay, so if I want to solve for my Fn, it's going to be Fgy. Okay, right, so that's going to be mg cosine theta, right, which is what I have right there. So 90 times 10 times cosine 35. Okay, so 900 cos 35. 737.2. Okay, right, and it makes sense that the y direction is bigger because it's under 45. Okay, it's under 45. All right, so once I have this amount here, right, if I have my FF and my FN, then I can go ahead and solve for my coefficient of friction. I'm going to go ahead and put a K there just to denote that it's kinetic. Okay, so mu K equals FF over Fn, or 516.2 over 737.2. 516.2, 737.2. Oops, I cannot type. 0.2 is 0.7, 0.7. Okay, remember the units cancel out. All right, so So this is going to be the coefficient of friction. Remember, it's almost always going to be less than 1. If it came out greater than 1, it's not necessarily wrong, but it might be wrong. I would double check it. Okay.